remove some of the logic from the app, brought to the game model, organized the files a bit better, renamed here, did a bit of a refactor and touch up in our files. But the problem persists. We still cannot call this function without causing an infinite loop in our application. And to fix this, we already said that we need to give them this isn't check. No, here we need to have a should verify check property in our check valid move. And now I want to send this to false whenever this function is called, but without causing all this repeated structure from all over the place. And this all over the place is actually square.piece. It's the piece that get the valid moves here that's causing the problem, because it goes somewhere else and then comes back here to the move validation service. So this flow is not good. What we want to have is our app.ts calls the game model, which calls the move validation service, which calls whoever it needs to be, but not the game model nor the app, right? Doesn't want to call the cycle. In this case, it called the pieces, but the pieces don't call anyone else. It returns to the move validation service, which recalculates everything, brings back to the game model, which of course will update in the app.ts. So we have here 4 steps to be done. app.ts, so the user interaction, comes to the game model, which comes to the move validation service to make sure that the moves are valid, right? And this move validation service needs to ask for the possible moves of this piece. Okay, that's the 4th step. And now we just return all back to the step 1 and show to the user. Go and come back. Simple flow, but quite important. And to be able to do this without the square piece calling the move validation service, we're going to need to change stuff, right? Let's open here the pawn piece model like we had before. And all of these piece models, the pawn, the knight, the king, the bishop, and everything, they call 2 functions from our move validation service, which is get valid moves for row and column and the check valid move. The check valid move is also called here, so you can say that all of them actually depend on this one, depend on this check valid move. And look at this. Check valid move needs a board, a square, a target coordinate, some more information. Here the same, a lot also of other configurations that needs to be sent. And this doesn't make much sense. Like they'll have a board inside the piece. That's weird. A square, I can deal with it. But the whole board here, for me, doesn't make much sense. So let's get our hands dirty and refactor all of this and see how we can transform this code here, which is quite messy, into something that can be used in our move validation service without causing any infinite loop. The main idea here, it would be for, let's say here the pawn piece model, to instead of checking the valid moves itself, we return to the move validation service the moves that we want to check. It's as simple as that. So it's going to cause quite a bit of refactor, yes, but the idea is quite simple. We can imagine that instead of returning then this forward move, diagonal, and the valid moves in the end, we're going to return something around this. Let's say check move. And then we're going to say, okay, the coordinates of our move, it will be this one. Coordinates to be this one. But just here, simple algorithm, okay? And this true. What is this true? This true is the move validation, check move, let's move, which is block if opposite color. And then I'm going to say here, block opposite color, true. Now we make a list with all these moves that we want to check. For example, here the forward move, return to the move validation service. Here, replace this for this new validation. And then this move validation service in itself calls the check valid move. That's the idea. And does it make sense to you that we replace this loop that we have, cycle in our code, for something a bit more generic and something a bit more extracted, and then each file will take its own responsibilities. Let's see how this would look like for all of these different pieces, right? Like we have here the rook, the queen, the knight, and stuff. All of them have different logics, so we need to accommodate all of that. And to start with it, let's start from the piece model itself. This get valid moves, I'm going to rename itself and say just get moves, because not all of them will be valid, right? We're going to make the validation later on. We don't receive the board, and we do need the last move, but we don't need the square per se. What we need is the coordinates. So the coordinates, I'm going to change here for a coordinate model. And we avoid a bit of the square importing a piece, right? Because the square has a piece in it, and then the piece receiving a square as a parameter. I don't like it that much, so I'm going to use here this get move, sending a coordinate, and possibly a last move. Going to return an array of move model? No, probably not. What we're going to need to return, it's a new interface that we're going to specify. Maybe here the move validation service, no, probably somewhere else to not cause any loops, any circular dependencies. But for now, let's write it here. What do we need to know for this move validation that we need to do, this possible move? Let's say here, possible move. What we need to know, we need to know the coordinates that it's going to be going to. Here, coordinate model. Let's open the pawn. We need the coordinates. And we need all of this information here of the check valid move. So block if opposite color. Good here. Let's call this target coordinate. Block if opposite color is type of boolean. Block if empty is type of boolean. Should verify check is a type of boolean. But we also need to allow, like here, this is the what we need for this movement. It's these ones. We don't need the board and square. With this information already have. So we're going to need these four. But we also need information for here, for the row and the column validation. So we're going to get this and put all of it here. See that this whole configuration here is our row and column volume, row column valid move check. Let's just check it here. Row column config, like so. And to not mess up both of them because they're slightly different, I'm going to add this inside a new interface, which will be single valid move check. This is just for a single one. And now add it here. So single valid, no, single config. And to be a single valid move check. We have then the should verify check, which goes for both of them. That's why it's outside. And we may also have more information that we need to add, but as of now, this is what I have in mind. Let's now bring this possible move to our piece model, because now we're going to return an array of this possible move. Let's add this import. We need to change later on, like the position where to be, to not be in the move validation service. But for now, this is fine. We let it as is. All of this change, so the get moves now, need to be implemented in our piece models, which extend, of course, the piece model itself. So all of our piece types. Let me create it here. Like so. No, this is fine. And here we have then our function. Probably going to need to import this, add all missing imports. Okay, have the coordinates and the last move. The pawn is the only one that needs the last move, right? All the others, they don't need to check for that. So I'm going now to bring this. Let me just return here an empty array just to stop complaining and add this to all of the others we have. Removing then the last move as it's not needed. Add all missing imports. The queen, let me copy this. Let's go for the queen. Imports, the knight, adding more missing imports, the king, and I think we're missing the bishop as well. Not sure I have it here. It's missing this import and the bishop. It's missing. Okay, this is done. One problem less. What we need to do is then start implementing them. I'm going to close everything again. Open the move service, move validation service now. And okay, here we already have get valid moves. Now it's get moves. We don't send the board. We send the square coordinates and the last move. These valid moves is not called valid moves anymore. It's the possible moves, which is an array of possible moves. And now these possible moves will be used to call these functions here. Check valid move. We don't know how to do that yet, so let's give it here to do. Convert possible moves into valid moves. And then we're going to return that, or no, just return empty array. Okay, step by step, always step by step. Let's get then our, maybe start simple. I'm going to start maybe with the night, because the pawn is one of the most complicated ones. And the knight makes here a check for 8 possible movements, right? The check will move, board, square, and have the row plus 2, row plus 2, and all of this. These ones are our array that we want to send here in this get moves. So let's return it directly. We'll have an object, which will be then, I forgot something really important, but let's give you the single config. It will have this as the target coordinate, if I'm not mistaken. That's what I said. Yes, this is the target coordinate. Let me get the row and the column here from the coordinates. Like this. Single config, it's missing, of course, some more information, which is the block if opposite color and block if empty. This by default can be false or undefined, so I'm just going to let it be here optional, and then we can just say the target coordinate. Fine. We're also missing though the should verify check, and this should verify check here needs to be true, or we do the other way around, and if like block check verify and make this optional, so we don't need to type this all the time here. But what we are missing is something that identifies should we use the single config or the row column config. We could create a property to control that, or we could just make these two optional as well. So it's an interface with all the properties optional. And if there's a single config, we check for single valid moves. If there's a row column config, we check for that. So you don't need to be double specifying everything that is going to happen. This then is one of our movements. It is the first movement we have here. We could now just repeat this. Let me put this in a new line. Repeat all of these movements. And maybe, yeah, so just we have 8. And we repeat what we had here before. So row plus 2, here's row minus 2, minus 2. Here's 1, 1. Here's minus, and this is 1. This is 1. So row plus 2, minus 2, plus 1, minus 1. And now have column plus minus, here, plus minus, but 2, 2, 2, and 2. That's it. These get valid moves don't need to be used anymore. And now we have the get moves, just returning all the possible moves. I'm going to remove all of these imports, see how much we can clean up here. And this is the implementation then for the knight. Let's continue and do for the other pieces. Next, we'll go for the bishop. Let's go for the bishop. And the bishop is slightly different, of course, from the knight, because we're going to use the get valid moves for row and column. This is the idea that we have. And what we basically need to do here is to send this in the array, saying that it's the row column config. So row column config, it's this. We of course need to grab the coordinates here, in this case just the row, not from the square, directly from the coordinates. And now we just add all of those. No, this one first. My bad. new object, row column config. Let me copy paste, right, to be easier. So 3, 4, and now I copy this, bring it here, like so, and the last one, like so. Okay, can remove this. No more need for this function. I can already remove this. Don't know why I just comment out. Let's trust what we're doing. Bishop done. What is the next one? Maybe the rook. Let's go. So rook piece model. Again, we're just going to return row config, sending this. It's pretty straightforward. Pretty straightforward. I don't know if we're missing anything here. Maybe we are, but as of now, I don't think so. We can just adjust later on if needed, right? Not taken from the squares, taken directly from the coordinates. We need 4 as well, of course. Let's add them. So 3, 2, 3, 4. This is the second. Just going to replace it here. This is the third. Going to replace it here. Okay, everything fine. And this is the last one, the fourth. Just going to replace it here. Nice. Can delete this. Done. This is the moves for the rook. Let's go for the queen. Maybe first remove here this and use the imports. Like so. The queen, as we saw before, it's the movement of the rook and the bishop all together. So let's go here and grab our row and column. It's not imported here, and it's missing the coordinates. I deleted something there when I was importing all of it. So let's adjust coordinate, add all missing ports here, like so. And now return. Let's go. Move within row, move within column, and move within diagonal, just like we did the comments before. The row is this one, if I'm not mistaken. Yeah, it's this one. This is the column. Copy paste, and the bishop here. Okay. Let's go with this, and now I can remove all of this code. No. Struggling a bit, it seems. Here, that is done. Now I can remove all these imports. And with this, we finish the queen. Let me close this tree, and I'm opening now the king. The king has very simple, just like the knight, at least for these first ones. But then we have the castling. The castling, it's a bit more interesting because we have board gets square on coordinate and everything. Let's see how we can deal with this specific logic here in our new method. But for now, let me start with const possible moves, as we may need to add, as we have an if, so we may need to add. I'm going to start an array first instead of returning directly. It's the king and the pawn that will need to do that. For the others, we can just return directly, and now return the possible moves. In these possible moves, we're going to push. We could use this logic for all of them, but it costs a bit more, right? To give push, push, push instead of just returning a full array all at once. Although the code probably could look a bit better. Just going to say here, single config target coordinate is this one. Like so. Let me get here the coordinates. Like so. And now we just need to do this 4 times. So maybe I copy all of them one by one. Here. Here. This one, I may speed up this in the editing. Let's see how I do. And now 4 more. There these 4 here, so the diagonal, right? We have there the up, down, left and right. Now we have the diagonals. Could probably be editing it to be faster than copy and pasting this, but now it's almost done. Okay. This comes here. Let's just say here, row and column. And here we're going to say diagonal. Diagonal. Nice. That done. We can comment this out just to show that we did, and we can go then for the castling. Let's bring this here, this if at least, and look at the logic. How can we improve it? First, okay, where I can start this with the king row, we need to know that. The interesting part of the castling here is that we need the board in order to get the coordinations here of where is the rook and if there is any pieces here, and then verify if this rook moved or not and if this piece exists. Again, we don't want to use the board here inside of our piece models, so we're going to add the possibility in our possible move to accept logic like so. Let's first start here. It can be in the single config, it could also be directly here in the possible move, but I think it makes more sense directly into the single config, which I say must be empty coordinates. This is an array of coordinate model. Of course, completely optional because only king will need that. And now we can add these 2 coordinates or these 3 here in order to identify which coordinates need to be empty. And we can add a new one, which is the square rook king piece here, new property, which will be must be not moved rook. Like this array of coordinate model. Again, can be undefined because this is being used only for the castling. Let's add this now for our king piece here. So we have the king row. We're going to say possible moves dot push. Here, open new one, single config. This will be target coordinates. What is be the target coordinates? We already have it down here. It's this one. This is the target coordinate. And now we need to specify the must be not moved rook. Let's open it here. We need to open this in a bigger one. So target coordinates like this must be not moved rook. This is also an array of coordinates. So it is this one that we're looking for. This is an array. So let's have it here. Array of coordinates. And lastly, must be empty coordinates. Array containing this one. Let's add it here. And this one. Okay, this is our first castling option. Now, let's add just here comment, so castle king side. And now let's do then the castle queen side. Possible moves, push, which we added everything like before. But now we're talking here column 1, 2, and 3. And we're talking here the target coordinate being column 2, and the square here being column 2. So here, column 0. No, sorry. This one, target coordinate, it's the column 2. And we're checking if the rook is in the column 0, of course. Okay, this is the queen side. We do need, though, to add this type, this movement type. This movement type could be here, like as part of the move. So this valid moves, as we've seen, it's a move model, which has then the move type, which we need to specify, and also the coordinate. So we could change this here, this possible move in our single validate move check to accept, instead of a target coordinate, accept a move model here. Like, instead of just accepting the coordinate, we accept the move model. I don't like it that much. I prefer to have it aside. Just give it here. So move type of type move type. Not mistaken. Yeah. Because if I add this as a move model, and then later on, this needs more and more information, like inside the move, for example, this gives check, we don't care about it here. Like, we are just adding more information on top of that, so I don't want to mess these two things up. I just want to have a coordinate, it's where I want to go, and what is this type of movement. All of it, by default, let's say it's undefined, because then we transform it into a normal, so we don't need to specifying all of these types we're doing here. But for this one of the king, we will need to specify the move type being move type castle queen side, and here castle king side. Okay, with that, we finally can remove all of this code and go for our pawn. Let me just remove this. Okay, better, much better. Let's open our pawn and start with working on it. So we first bring here the square coordinates, or the coordinates per se, not the square anymore. We also need, just like the king, to have our possible moves. Let's add it here. And now return the possible moves, as we're going to have several checks. And even the basic movements here use the square piece color to determine the starting row. So this is the basic row, right? Like the basic movement. Check basic movement to try to go 2 squares in front. We can add here the same logic as we had before, but we can also refactor this and work just like we did in the king, having the king row. Let's call this the starting row, and this dot is white piece. If so, the starting row is 1. If it's black, the starting row is 6. Okay, this is one possible movement. Now I'm going to verify if the row equals a starting row, and then we're going to add this. So this is the one we want to use, row plus 2 or row minus 2. Let's work on that. Possible moves dot push, here to be a single config, it's a single movement. Target coordinate, it's what we have here. And we also have the first of our options that we need to do, which is block if opposite color. If I'm not mistaken, let me just double check here, check that move. Block if opposite color. Yeah. Here, pawn, pawn, pawn. So black if opposite color, true. Like so. This is the first possible move, but it's not row plus 2, it's row plus or minus 2. So what about we create here another variable, which I'm going to say direction equal this dot is white piece. If so, we are going up the board, right? The white piece is always going up the rows. I'm going to say 1. Otherwise, if it's a black piece, it's a -1. And now here, what we're going to do is a plus 2 times the direction. So if it's a black piece, we're going to say here -2. So multiplying 2 by -1, we'll have a -2. So row minus plus -2, which is of course row -2. And with that, we do this value, this check here, and this check here. Okay, that looks good. This one is the first starting movement of the pawn, which can go 2 squares, right? 2 rows in front of it. We now can do all of these other moves in the same idea. So let's copy paste this logic, just check it out what we can do. The move type here, row equals 6. promotion, otherwise normal. We're going to change this slightly by saying if this is white piece and row equals 6, or we add here another parenthesis, or this is white piece, this is not a white piece, so it's a black piece, and row equals 1. If so, we're going for a promotion. This is, here and now here. We're going promotion, otherwise it will be a normal movement. This one. Let me get here. Then the forward move, check valid move, forward square. We don't care. It's just this one. We're just going to add, so possible moves dot push single config target coordinate. It's this one. And we're going to say also block opposite color true. This is, the forward move. And we also then we're checking if forward move and sending the type there. As we can already send the type here, it's what I'm going to do directly. Type, move type is type. It's not just move type, it's already the same variable name. Okay, that's nice. Let's add the following one, row plus 1 times direction. Same here, plus 1 times direction. Yeah, like so. Column to be column minus 1, just like we have it here. The block of opposite color false, but the second property is true, which is block if empty. So let's grab it here. Block if empty, true, because you cannot capture if you're not there, right? This is then the capture on one direction, and this one is the capture on the other direction. Can remove this, we don't need it anymore. And with that, we removed all of this and all of this. Now, the only thing that we are missing is the very specific en passant. Very, very specific. Let's bring this if here. So I'm going to actually reorganize. I'm going to say here. So normal move. Just have some comments here. Capture moves. Then now, double move, double initial move, like so. And here, en passant. Row 4. No, it can be row 4. It can be row 3. It depends if you're white or black. But now let's just do the white. Let's check row, last move, piece, type on. Everything here is exactly the same. But now we're going to say possible moves dot push. Again, it's a single config value, which has a target coordinate of this one, like so. Am I adding something more here? Am I missing? Yeah, I think yes, I was missing one. So I have the target coordinate, and we have a move type, of course, en passant. Can remove this, and this is the en passant for white. How can we improve this code here to also accept the movement for black? We need to check the things, the validations which are made for both of them, which is if the last piece was a pawn, to move it was a pawn, as you can see here, it's the same logic. And this one, if the last piece moved in one of the side columns, so we can remove this as well, because these are the two logics which are for both white and black. Now, the row, the last movement color, and the last movement row, they change depending on the color of our pieces. Let's put this in the last ones and check it out. So if this dot is white piece and row equals 4, We can add all of these actually inside. Yeah. And let's move. It's possible to find, yes, of course. And let's move row 4, like so. So we just basically put everything inside one big parenthesis here. And now I'm going to say, or this parenthesis, or this other parenthesis that I'm going to give here. And the last of our validations. This other parenthesis, as you can imagine, is a validation for black. So if it's not a white piece, row is 3, color of the last movement is of white, and the row that the last movement went, it was the column 3. We're going to push then this row being the current row that we have, because if we're 4, we go to 5, if we're 3, we go to 2. So we're going to say row plus 1 times direction, just like we had it here. So if it's black, we go down the board. If it's white, we go up the board. Move type en passant, column is the same. And with that, we can finally finish this function here, cleaning up all of this. Now, imports. We have our pawn model also ready, which maybe could be slightly simplified here, but for now, it's fine. And here is where we finish this video because it's already big enough. And we're going to continue with how to adapt what we changed in the piece models into our move validation service in the next one.